So we are going to continue with introduction to data science and a bit of what we've covered, a recap of what we covered yesterday based on the curriculum that we have on our system. What we did yesterday is a bit more easier to understand content. What we have here is a bit technical, and we are still tidying up. We need to do a bit of more updates. For next week, we will introduce you to some components of some packages that you can use for data science, specifically definitely NumPy, Pandas, Matplotlib, yeah, and maybe some other sci-fi like that. So some of the content we have here depends on that curriculum. So that packages, so we'll not go into them for now. So let's get into it. So I'm not going to go into what data science is. We've covered what data science is. We do have types of data. We have structured data, which is data
Kusan biyo da ba da suke wannan nashi Umar ya kira ni Umar na Mexico ya ce shi zai je wa
Salima, can you make one of the posts to meter? Yeah. So we do have a structured data, which is data that seeds, for example, as the data you have in your Excel separated into rows and columns is well organized. You can easily understand what it is. So that is a structured data. We have on a semi-structured data that is somewhat structured, like Wikipedia pages that all of them have some distinctive form of calculation.
Dr. Ibrahim, what you need to do is mute all.
Shamsu, you are co-host. Can you do that? Otherwise, I need to. Okay.
Yeah. So I said what you should do is to mute everyone. I can see now everyone is muted so that nobody can unmute themselves. You can you make me co-host?
You are already.
I'm not co-host. You are the one co-host. You can see one Shamsuddin only. Make me co-host in Shamsuddin, not the one.
Oh. Yep. You are co-host now. And then we have fully unstructured data, which is just any kind of random data, your observations, the text we have on the social media, records of sales, whatever record that you just see without any form of structure or organization. That is fully unstructured data. And then we've discussed a bit of this yesterday, how you can get your data sources. When you apply, for example, for structured data, when you apply for this Idaho data science, you have a form where you fill in your name, all your details. So whatever you fill, we have that record, and it's organized into your name, details, background, and all of that. It's structured. We know whatever detail it is. Unstructured data is gotten anywhere, your observation, what is on social media, logs, whatever you do on your computer is logged somewhere. All those kind of logs that somewhat means little, that is unstructured data. And where we can get that semi-structured data, we can get it from websites. Wikipedia has one. Here we have social network graphs can be great sources of data about people, from where they are, what kind of information they do, what their behavior even our web browsers to our, they do track whatever we are doing. That's how we get advertisements. So that is another form of unstructured data. So what you can do with data, first of all, we have data acquisition, and that's how we collect our data. The first step is data to collect our data. It's not always easy, especially when we say data acquisition, we are referring to, for example, getting a new data. We do know there are many places we can get data online, data that's already been collected, prepared, and whatever. But many times that's easy to get, but many times you need to collect your data from primary sources, and it's not always straightforward to get that data. We need to come up with techniques that we can be able to get our data depending on what we want. For example, if we are collecting data from Twitter, then how do we do that? We have a Twitter API that we can use to collect it. Then we have data storage, how we store our data. It can be difficult depending on the kind of data you have. Difficult in the sense of, if your data is very big, then it becomes computationally expensive to store the data. And then how we organize the data, especially if you have an unstructured data, or if it's structured, what form can you store it? If you have a structured data, then it's easy. You can store it in the form of databases using tables, and all of that will come to that in the next slide. And then we have data processing, which is an important segment of data science. Is the most exciting part. Joining it involves converting data from its original form into a form that can be used for your visualization or training your model. We do know computers understand, there is a specific language computers understand. For example, we say computers understand ones and zeros. So everything you have needs to be in that form. And then, so you need to convert whatever form of data you have into a way that is meaningful to your computer to be able to do whatever you want, visualization, machine learning, making informed decisions, and all of that. And then we have visualization, meaning sometimes you can look at raw data, you are just saying numbers, whatever, you don't know what that means. When you visualize, you can have bar chart, pie chart to see variation variables, and all of that, which is easier to understand. Then, of course, we can train a model, any machine learning model, for forecasting. If we have data about the weather, humidity, precipitation, and all of that, then we can use that to predict whether it's going to rain, whether it's going to be humid, and all other parameters. Or if you have, let's see, data about shopping, people, you have a supermarket, you have record about people coming, going over the years and the rest, then you can know at what times, at what season do people come to your shop. You can use this to, for example, decide how many counters do you need. You may have 10 counters where people can check out if they finish buying their products. So when you have an idea of, at each period of time, how many customers are you expecting, you can know how many people to put on the counter. This will save you cost of personnel. So we do have a challenge here, but I don't think you can take this challenge. You can click the notebook, but because we've not done any of the libraries, so you can skip this until after we've covered the libraries. Yeah, we need to use matplotlib and all of that. Request that you are not familiar with them. So as I've said, next week we will cover, on Saturday we'll cover some of the common libraries, then maybe you can come back to them. So we can go to another component that is, I've touched a bit of it yesterday. That is data ethics, which is one of the most trending areas of artificial intelligence now. When you go and search for responsible AI and all of that, you can see many people talking about responsible AI, which is within the scope of data ethics. Or specifically, you can look at keywords like fairness, reliability, privacy, inclusiveness, transparency, and accountability. This is, yesterday I've talked about philosophy, meaning we have this access to powerful things, powerful technologies, about people, about our environment. We need to use these tools that we have at our disposal in the best of manners, that we do not negatively affect people, we do not invade their privacy, we do not risk them based on the data that we have. So I will try to go a bit and discuss some of the things. So the word ethics comes from a Greek word ethikos, which is from ethos, meaning character or moral in nature. So ethics is about shared value of moral principle to govern behavior of society. Ethics is based not on laws, but widely accepted norms, what is right and what is wrong. It's not about what the law allows, but it's fundamentally about what is right and what is wrong. And that is why in many instances, we see it based on ethical consideration, ethical whatever. It's all about not about what the law says, but about what is principally right. Is it okay for you to say a word to somebody? Is it wrong? Things like that. Is it morally okay to do this or that and all of that? However, ethical consideration can influence corporate governance initiatives. Many a times when people try to act unethically, then we can have laws that ensures that doesn't happen. So we have data ethics. It's a new branch of ethics. Initially, we have ethics is in everything, but because of the how powerful access to data and manipulation of data becomes, we have now a part of ethics, which is the data ethics, which we focus about studies that evaluate moral problems related to data, algorithm, and all of that. So when we talk about data, we are interested about things that has to do with how we generate data, how we record the data, how we curate it, process, how we share it, and then how it is being used with algorithms as it relates to AI agents, machine learning, robots, and all of that. And then we call it, we have topics like responsible innovation, programming, hacking, and ethical codes. So applied ethics is the practical application of all of whatever I'm talking in the context of what we do. You have ethics, the theory. When you are talking about ethics is when you are doing your machine learning, when you are doing your data science, when you are doing all of this, you apply your ethics, you apply the ethics that you've learned. Ethics culture is when in an organization or even person on what you do, you takes into consideration ethical principles. They guide whatever you are doing, consistent, and then it can be applicable to more than one scenarios. Then we call that ethical culture or ethics culture. So some of the concepts we have, as I've said, different concepts depending on what organization is. This material we're using is from Microsoft, and then they have the Microsoft Responsible AI mission. It says we are committed to the advancements of AI driven by ethical principles that put people first. Put people first. So identifying six principles of the framework, accountability, and generally this is consistent in almost all responsible AI guidelines or principles. We have accountancy, transparency, fairness, reliability and safety, privacy and security, and then inclusiveness. For accountability, makes practitioners responsible for their data and AI operations and in compliance with ethical principles, meaning whoever makes use of AI data and all of that, then he is accountable to whatever happens based on what he come up with or what he developed. We have transparency in a way that whatever you are doing, for example, we have the OpenAI, the makers of ChatGPT. So transparency has to do with whatever data or AI or machine learning you are using is understandable. That means it can be interpreted to the users, explaining what and why behind the decisions. So meaning whatever model you are building, you have to, it has to be, people need to be able to understand what happens behind the scene. And then we have fairness, which means all people are treated equally. When we have fairness, I didn't see bias here. Then we also have bias. I will explain it later. And then we have reliability and safety ensures that when OpenAI happened, we've had a lot of discussion about how reliable it is, not just reliability, but in terms of safety. And then we have things like if people have seen stories, not sure how verified it is, people asking, and yeah, it do happens, people asking these like language models how they can commit crime or how they can do some things that are not ethical. Now they do have mechanisms to try and fish that out. But yeah, that is reliability and safety. And then we have privacy and security, meaning whatever data we are getting. Now we can get our data from Twitter. Twitter tells you that whenever you get a data, you have to make sure that the personal information of people is not shared, is not used, or not just any personal information, not just the names of people, but anything about information that can be traced back to people, like addresses and all of that. Just a minute. And then inclusiveness, when we talk inclusiveness in AI, it means that your solution is intended for everybody, not just developing systems that they are tailored just for people while ignoring others. For example, let me give you a typical example of maybe things you can understand. For example, if you have, and this is a problem that we know we have in Nigeria, for example, we do have our classes, some of our classes are upstairs. And then we have no way of people that maybe are disabled that use people that can't walk, they use chairs, what is it, wheelchairs to walk. They don't have, so they've been excluded from using those kind of systems. So that's what we mean inclusivity, meaning that your solutions are for everyone. And right, for example, right now, most of the solutions that we have uh, are not working efficiently for our people. In other languages, we have many systems in English, but we don't have any in, for example, Hausa or whatever, we have very few. So inclusiveness is meaning ensuring that most of your systems cover as wide range of people as possible. And then we do have bias, meaning you ensure that your data or your machine learning model or whatever is not biased toward segment of people or segment of that. So we do have some challenges in ethics. Once ethical principles are defined, the next step is to evaluate our data and AI actions to see if they align with those shared values. So we do have, you can divide whatever you have, whatever you are doing into two segments in terms of data collection and then algorithm design. You divide all of, for example, this guiding principle, so you can categorize two things in what you do with, that is data collection and algorithm design. In data collection, it has to do with, for example, personal, what happens to personal data or personally identifying information of people. And all of that with, for example, algorithms design involves collecting, creating data, then using them to train and deploy models to predict the outcomes. So the ethical challenges, for example, in terms of algorithms, in terms of data, we are talking about personal information of people or things that can be used to identify them. But when it comes to algorithms, after you collect the data, you prepare them and you use them. So do you have a data set bias, which we do have in many instances? What is the quality of your data set? because if you have a poor quality data set, then whatever model you have will not have good quality. If you have data set bias, your model will be biased. Do you have unfairness and misrepresentation of algorithm and all of that? So these are, for example, the kind of challenges that we can have in terms of data and in terms of algorithm design. And then there are things that in both cases, ethics challenge silent areas or actions to counter. You encounter conflicts, whatever you have. Let's take a look at some of the things that we need to, questions that we need to ask ourselves. Data ownership. Some of you may be familiar with some of these things. They apply to even the data we collect with questionnaires. When you distribute questionnaire to people, you have to tell them who have access. You are collecting their data, their personal information, and their views related to matters. For example, then data collection often involves personal data that you can identify people. So we need to know who have access to the data. For example, who owns the data? Is it yourself or your organization? Usually, if you are doing research, for example, you are a student of BUK, you have to say, my name is blah, 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 blah. I'm conducting a research in Bio University, Kano. You need to let people know who has access to that data. And then people need to know what rights they have. And then they also need to know what right the organizations have regarding the data. And then that is what we call informed consent, meaning people agree. You don't just impose it on people. People agree to be part of the study. Willingly agree to give you the data. Did the user give permission to take the data? Did the user understand the purpose for which the data is used? Did the user understand the potential risk, if any, for his participation? This needs to be clear, and you need to collect the consent. Usually somebody need to sign. You can see this clearly with questionnaires when you are collecting, but for example, from other sources, especially online electronically, you have a long time whenever you want to use, let's say, Twitter or Facebook, and nobody rates it, everybody just scroll down and just accept. So when you accepted, you've accepted to whatever they've already agreed to. If they agree to people collecting their data and all of that, so you've also agreed that when you are getting that data, you accepted all your rights. That's why you are using it for free. Then we have the intellectual property. So people need to understand, when you collect the data, did you collect the data to have economic value to user or business? Does the user have intellectual property here? Meaning, if you are collecting data and you want to monetize it, get money out of it. So the people whose data you are using, do they have access to the money? And does organization have intellectual property here? You are the user, and then the organization is, if you are from, let's say, BUK, and if this right exists, how are we protecting these rights? We've seen how recently places like Twitter have now started monetizing original content. This has been happening maybe for a while on YouTube. You create your content, they are getting money out of it. So you need to get when you create a new video, a novel video that is your own content, they get money out of it. So you need to also benefit from that. And that's why they are giving the money, not because they are interested in giving free money, because they are getting money out of it. So you also need to get a piece of the cake. And then important component is data privacy, or information privacy. Refers to preserving the user privacy and protecting the user or trespass to find information that can be used to identify them. Is users' personal information secured against hacks, leaks? We know what happens with the WikiLeaks. Is the user data accessible only to authorized users or contacts? Is users' anonymity preserved? When data is shared, can the user be identified? Can a user be de-identified from anonymized data sets? Whoever worked with Twitter data knows Twitter has a strong policy when it comes to data collection and data sharing. as far as Twitter regulations is concerned. I'm giving you an example because it's there to understand with Twitter. You can collect tweets to do your search, like sentiment analysis, if you know what that is. But then the condition is you cannot share whatever you get. First of all, you need to remove all user identifier information from that tweet, and then two, you cannot share it. If you need to share that, you can only share the tweet ID, because it's somewhat semi-structured from that segment. Every tweet has its tweet ID, and whoever wants to use that data needs to get approval from Twitter and then to collect the data from the Twitter ID. And then people need to understand the right to be forgotten. This is more commonly with when you are using, for example, service. What happens at the end of the search? Are you going to destroy the data, or are you going to share it? And then we have also questions: if you've already collected the data without consent, or by unlawful means, are we compliant with government regulations for data privacy and all of that? We have issues that has to do with bias. Did we record representative set of data subjects? Did we just collected curated tweets for various biases and all of that? Okay, how to understand this? For example, now you want to, and this happens a lot in Nigeria. Actually, most of the data coming out of statistics coming out of Nigeria is not that accurate because of data bias. You want to test some information regarding Nigeria as a whole, then you go and take your data in Lagos, Abuja, and then you sample, you take your data from Lagos and Abuja, and then you conclude about Nigeria. That will definitely not tell you the true picture of Nigeria. You need to collect data from multiple places, or you want to do your study in Kano, then you just take your data from metropolitan, and then you make a conclusion about the entire of Kano state. So data bias may arise from this, or you want to collect data, then you collect it only from men or only from women, and then you want to have a conclusion about the entire population. And then we have things that have to do with data quality. Did we capture all valid cases? Was data captured consistently? Is the data set complete for diverse conditions and scenarios? Is informed, whatever? And then we also I've seen some big tech companies trying to work on, for example, things that has to do with Nigerian languages, and then sometimes they find it difficult to get access to people who, I don't know if it's because they don't do their job very well or whatever. You see, they have a data about, let's say, Hausa language, but you clearly know that that data set was not collected by a person who understands the language. You can see it as that we've come across that. So all of this has to do with data quality. There are things that you cannot get, and then you just fill in whatever you want and all of that. And then we have algorithm fairness, meaning did we evaluate the model accuracy for bias, subgroups, and conditions? This applies maybe to all people that can relate to this more is people doing their research. You just want to have a good accuracy, so you even tailor your algorithm or in your evaluation to a way that gives you the best kind of accuracy. So that's not the right way to do it in terms of fairness. Did we scrutinize the system for potential harms? I'm doing research on this with large language models. Did they stereotype? Are they multicultural? Do they understand the cultural differences among people? And then can we revise data or retrain models to mitigate identified harms? So these are questions you need to ask when developing And then we have misrepresentation. Yesterday, I talked about data on its own. It cannot tell us anything, and it's not the truth, is subject to our interpretation. So we have questions about how we represent whatever data or whatever findings that we have. Are we reporting incomplete or inaccurate data? Sometimes people tend to do this to push one form of narrative. That's why you will be seeing data with full statistics that it's full of inaccurate, it's wrong, it's a lie, it's bullshit. But yeah, are we visualizing data in a manner that drives misleading conclusions? We've seen this a lot unfortunately, in Nigeria. Are we using selective statistical techniques to manipulate the outcomes? For students here doing masters or PhD, please avoid this. It's not just about getting the degree, but you have to, and that's why some of you may say this is boring, this is not data science, but this is important because you need to be responsible in whatever you do. So do not just select statistical techniques or algorithms to manipulate the outcomes just because you want to have an accuracy that is better than the baseline, or that with the base work, then you do that. And I know this happens a lot. There are alternative explanations that may offer a different conclusion. If there are alternative explanations, then you have to give that. And that's why, if you have some experience with publication, if we have some MSc students here, sometimes you see a reviewer will tell you, then what? You have your results 80, 90%, whatever. Then what is the implication? What does it mean? What caused the result to be this way? What happens if? So these are all trying to ensure that you really scrutinize whatever you have and you answer these questions. And then we have free choice things like the user questions, like the user understand the implication of making a choice? Was the user aware of other choices? Advantage can the user reverse an automated or influence choice later? So you can go over this on your own. This is an example of some ethical challenges and case study. This on informed consent. Let me read one. In 1972, this person, African American men who participated in the study, were promised free medical care, but deceived by researchers who failed to inform them that their diagnosis or inability or availability of treatment. Many subjects died. Okay. So it's a research, and the participants were promised some good medical care, but we are not clear to tell them about the risk that has to do with the study, and many of them died. We have data privacy. Netflix data price providers with 10 million anonymized movie rankings of 50,000 help, whatever. However, yeah, so this is data privacy. They think Netflix wanted to optimize how they recommend movie. We have a branch we call recommendation systems, whereby when you watch they know which movie to advertise to you. You have this, you can relate with YouTube. When you watch one movie, you'll be seeing, when you open YouTube, you see the movies that the videos that pop up. So Netflix want to improve that. So they give information. They already have about 50,000 of their customers, and they think they've anonymized any personal personal information or information that can be used to assist people. Notwithstanding, people were able to track back on the people. These are examples. You can go over them, and okay, you can go over all of this. We do have an assignment yesterday. Look, is it Lukman have shown you how to write Medium page? So I think you can go ahead and try this assignment. So what are you to do? You've learned about data ethics challenge and some of the case study reflecting on that. In this assignment, you pick ethics challenge from whatever you have. You describe a real world example of it. and then you provide a related resource, a link or reference to see it actually happen. And this is a Ruby to understand how good your assignment is. Exemplary, when you have one or more challenge identified, when the case study is clearly explained, and then when you have a link or reference to that, this is what is adequate, this is what needs improvement. So this you can do it in the form of medium page. It's good. You can have you start writing your medium page, then you can have data ethics, blah, 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 short form. Then you come and write about what data ethics challenge from whatever we have, you explain it, you write about it, and you do that. You can have a medium blog on that. You can use images and all of that. Yeah, so so let's go back to see what we have. I spoke a lot about, okay. I can understand some, now we are back to the second segment. That means working with data, and then the first part of that is relational databases. I can understand some of you don't have background in computing, so it's okay if you don't understand this. Relational databases or database is a complete course in university. I think in UK we have 2 database courses, in level 2 and in level 4. If I'm not mistaken, I took one of them. So, but I'll try to make it easy for you to understand what this is, but you will not be using much of it. It's just for you to know it for the purpose of the knowledge. But you, at the beginning of your data science journey, you will not be using a lot of SQL or any of SQL at all until maybe if you go deep, when you build your career in that, then some of the data you'll be using will come from structured manner, from SQL, and all of that. You'll know about queries and all of that. So a relational database at its core are tables. Just like what we have in our spreadsheet in Excel, we have a table of columns and rows. The rows contains data information we wish to work on, such as whatever. So as this, we have this table. So let's see the shortcomings of using the normal spreadsheet, of having tables like this. Meaning why we need to have a relational database approach, meaning tables that are related to one another. That's what the relational come. You are storing your data in a relation in form of tables that have relationship with one another. So we have, for example, this kind of data that stores information about cities, the country they are from, and the amount of rainfall in milliliters. So one of the most obvious problem we can see with this is we have duplication. We are having Tokyo, Japan, Tokyo, Japan, Tokyo, Japan. We can have a lot of this duplication. This may be very problematic if we have a large number of data sets. It will just increase the size of our data, and then it's just duplication. Somewhat duplication. The information here is different, but so we can change this how we present this data. Instead of having this way, maybe we can have the years so that we can have only one Tokyo. We have only one Tokyo here in Japan, then we have the years. But this also has a problem of, if we want to go to another year, 2021, we need to change our table entirely. We need to add a new column that will take that. So this is not also a good approach. Then that's how we come about with that, how the concept of relationship comes about with relational databases. So if we are to assume we have, we know that we want to store the name of country of cities, so probably this, we have this. For example, we want to store information about cities and country. So we have this table, city and table. So we can call this table, let's see, city. But when it comes to relational databases, we need to be able to uniquely identify each row in our data set, right? In our data. So you see, we can have city ID, meaning a unique identifier that you can be able to know, identify that. For example, most of you are students in, you all have a registration number. So that your registration number is unique to all of you. It's not, two people cannot have the same. So whenever we are looking for you, for example, in BUK, we use the registration number. We have your records, we have your name, we have your result, we have your number, you have your many other things related to you. But we say, okay, how do we identify everybody? Two people can have the same name. They can be from the same city, they can have be from many different places. How do you identify? With your registration number? And that's what we call primary key, meaning is the key to be able to identify rows in our data. And then we can have another table. This is table that shows the names of our cities. So now whenever we want to, we don't have to change the structure of the data. We can just continue adding more cities here. And then we have another column, another table. Let's see, rainfall, where we store the rainfall. So instead of, so this, each table needs to have its own primary key, meaning unique identifier. So this rainfall, we have its rainfall ID, meaning it identifies all of this. And then here we have city ID, meaning it will go to this other table to fetch the name. What is one? One is Tokyo, like this. So we call this foreign key because this is a primary key in another table, the city table. We have city table and we have rainfall table. This has its primary key, and this is a cell here that tells us which city we have, but it's just a key. All we need to do is come back to the other table to get it. So it's called foreign key. So then when you, and you see when we saw information like this, we have these tables. We don't have the duplication for names of cities and all of that. And then these tables are related to one another. This is a better representation. And this is what comes about relational databases. We can have as many tables as we want, all of them carrying unique information that can be used all together. So when it comes to retrieving information from a relational database, we have, okay, we don't have much time, but go ahead, Yahya. Okay, I think maybe you cannot unmute yourself. So not now, type in the question. I will answer it at the end. So we come to retrieving data. There are many languages that we can use, but one of the common one is we call it structured query language, SQL. Most commonly said, SQL is a standard language used to retrieve and modify data in relational databases. It have its syntax similar to, for example, we have syntax of programming of Python. But generally, when we want to retrieve information, we use the select keyword. What do we want to select? For example, here we see city. We want to select city from where do we want to select city? From cities. So this we do not specify whatever we want. So our output will be all our cities. So we have 1, 2, 3, Tokyo, Auckland, and all of that. We have that. So we can restrict it. We can select city from cities where country equals to New Zealand. So we are selecting city from cities where country equals to New Zealand. The only one we have is Auckland. So we have a more complex operation, which is the join, when you want to select from multiple tables. Actually, I'll not explain this. We are coming up with a new table because we are using inner join. We have another join, outer join, and all of these compound relations that I'm sure you will not, it will confuse you more. So I think that's it. I'll just skip the rest of this. So you can go and take a bit of this, but I don't think it's you will be needing it so much. As I've said, we haven't fully cleaned this material. We will clean it, and when we do, we'll take away most of these things. You don't need to do the challenge here. Just forget about it. So we have non-relational data, and this is what we know you will mostly be using data that are not in form of relational databases. SQL, most of data we'll use in this course will be in this form, mostly maybe in spreadsheet, in Excel documents, or in for now, take it for example in Excel document, but it will be seeing forms of data like CSV, comma separate values. I'm sure we have we have a note on that. Okay, all of this is SQL. You actually don't need all of this. We'll remove it from the material. Okay. So as I've said, we haven't done any of the libraries that we will be using. So we will not go into the programming component until next week, Saturday, when we'll treat pandas, all of the libraries. So this is working with data when you want to start your data science journey. Generally, you can use SQL databases and whatever to manipulate your data, but in many instances, it's not sufficient. Many times you need a programming language, and you can use any programming language for your data processing or data whatever, data manipulation. But generally, we are interested in, many people use either Python, R, or Julia, because these languages, a lot of work has been done on these languages to ensure that they are easy and have top of the shelf techniques that we can use for our data science. So we have Python, a general purpose programming language, which is considered one of the most best option for beginners, because it's very easy to use. Whoever has used any other programming language like Java, C, C++, you can understand how easy it is to use Python. You don't have all the whatever header files, hash include istream, or import Java, all of those jargons of C++ and Java. You also don't need to specifically, there's nothing like declaring your variables. It's easy. If you don't have this background, you may not understand what I'm just speaking about, but if you do, you can understand that Python is very easy to use. And then we have R. It's essentially a toolbox developed mainly for statistical data processing in mind. It contains a large repository that have a lot of packages, but R is not a traditional general purpose programming languages. So it's really used outside data science domain. And then we have Julia, is another programming language that's specifically developed for data science. It's intended to give better performance than Python, making it a good tool for scientific experiment. I haven't used Julia before, but I have used R and Python. and they are all very good for this course, and for most places you'll see people using Python because it's more robust. I'll have you can do many things with it, even outside data science, which in R you are restricted. So you may come to a point that there are things that you cannot do with it. If you are very much interested in R, maybe you can chat. I will send people your way, Shamsuddin. You can chat Shamsuddin. Yeah, he's one of the ambassadors of R in one of the few ones in Nigeria. So I will just talk about some of the libraries that we use, but we will see about the details of them in our next class. We have already made a tabular data when we talked about relational databases. So when you have a lot of data, and it's contained in many different tables, you can use SQL. However, there are many cases we don't have data in tabular form. So we need both these steps can be easily done using, we want to do a lot of manipulation with them, such as correlation, and many other things, visualization with it. We need to do them some way. And that's in Python, we have libraries to do that. And that's why it's easy. In some other languages, it's not as easy as it is with that. We have pandas, allows us to manipulate so-called data frames, which are analogous to relational data, relational tables. You can have named columns and perform different operations on row, columns, data frames in general. So for data manipulation, when you want to manipulate your data, we use pandas. And then we have NumPy, is a library for working with tensors, or let's see, multidimensional arrays. An array has values of the same underlying data type. Let's say we want to store our data. All the data have the same properties, so we can store it in an array, which is called tensors in NumPy. And then we can have other, like matplotlib we use for visualization, and then SciPy is for additional scientific functions. So normally when you want to use this packages, the only need you need to do libraries is to import them. By convention, we use import NumPy as an NP. You can use anything here, but by convention, just maintain as NP, import pandas as PD, import matplotlib whatever as PLT, and then we have many packages within subpackages within the SciPy package. We can just from SciPy import this. So in pandas, we have series, and which is data and series, and then we have data frame. We will come to this actually after we take our class on these libraries. You will not be able to understand this until we have the introductory class on that. So let's see what we have finally. Probably also here we need to, we need pandas and all of that. Dealing with missing values. All of this, we'll come back to them. We can do them when we are doing the libraries, so that you can understand. Okay, I will stop here because I'm at the top of the hour, and Shamsuddin will have some things to share with you. So go ahead, Doctor. Doctor, you have the floor.
Okay, thank you everyone for joining today's session. Thank you, Dr. Ibrahim. I believe today it's like theory today and yesterday, right? Because it's just a bit of introduction on what we'll be seeing in this course. In the next few weeks, coming weeks, your hands will get dirty using Python, using the data and whatsoever. So don't feel somehow that we started data science, but you have not been seeing what data science is. For example, you have not been seeing how to make a chart, how to make plot. All these things will come in few weeks. Today and yesterday, Dr. Ibrahim took us to a general tour on what data science is, to general landscape, and what we will expect to see. So today, what we have seen and yesterday is just introduction. Inshallah, next week, we'll dive into the most important part of data science, the tool we're gonna use. We'll dive into pandas and NumPy and matplotlib. So next week, we'll give you a very, even though some of you have done this in Python, but we want to give you a very general introduction to these tools because you study them yourself, self-study, but we want to dive into the practical session with you on how these tools can be used. So inshallah, from next week, we'll be having a total introduction. And let me share my screen to just show you a touch on can you see my screen?
Yep.
Okay.
Appointment. Yeah.
Oh, appointment again. Okay. I don't want you to see appointment. All right. Okay. So let me share again so that you can see what I want you to see. Oh, still seeing this.
We're still seeing appointment.
Huh?
Password.
Yeah, I know. So just to make sure that we are in the same stuff. So you can see this is our GitHub repository for data science. We're gonna upload our recordings for yesterday, for today as well. Here we'll upload this. You can see here we have introduction to data classification and whatsoever. And this one will be covered, I think, next week. Oh, is it what you did, Dr. Ibrahim? Or
yeah.
Okay. So we will have another, before we move into data preparation, we will have another column now to put introduction to pandas, NumPy, and whatsoever. And we'll have, I will possibly maybe present those stuff next week. And from there, we'll dive into, you can see we have very exciting stuff to do using math visualization, all this stuff. So this session in data science will give us, a kind of opportunity for us to master the tools that are for data science and exploring data, visualizing data, cleaning data, and all this stuff. So this is what is expected in this session. Also, I think Lukman also, we are missing your slide. We'll upload the slide for Lukman yesterday on how to make blog posts. What I will expect for us is that please, can you make another, for each one of us before next week, can we create one blog post on what is data? Just explain what is data science, the general stuff in data science, what it entails, and just create a blog post in Medium, create the account, create a blog post, write something very good about what you understand about the introduction we did in data science. And then from next, hello,
Doctor. So there is an assignment within the data ethics that I give them. So
okay.
They will do that in the Medium post. I hope you followed that.
Okay, thank you. Yeah, so the main idea is just for you to start practicing, the skills you learn how to create Medium blog posts in this week. So just you write those things. What we expect as well, for each of these sessions, when we come to them, they have an assignment. So for example, if we go to data preparation, next week, inshallah, we'll dive into the detail for this. You can see we have what we call pre-quiz lecture. For each lecture, we have what we call pre-lecture quiz, where you'll go there and try to answer some questions, data preparation. Which one of these is part of data preparation process? You select them and move on. You see it's not. So this is what we call pre-lecture quiz before you even start understanding. Then after we finish, then we have what we call post-lecture quiz. This is just to reinforce your learning. So you can see post-lecture quiz. So now you understand, you go through everything here, you understand, then you can take post-lecture quiz. then you can evaluate yourself before you take this lecture. Do you understand this stuff? So if you understand that you are always, making it, you are selecting the right answer, then you understand the concept. So this is the essence of what we call pre-lecture quiz and also post-lecture quiz. We expect each of you to take this lecture. But at the end of each session, we have what we call challenge. So a challenge is something that you can practice what you learn. So for example, you can see here, we're gonna learn a lot of stuff here. For example, dealing with missing data, you can see them, exploring data frame information. And when we finish it, so we expect each of you to do challenge for each one. So if you go for the challenge, you will see the challenge is explain what you are expected to do. So I'm just giving you a general overview of what we'll be doing. So you can see this is the assignment for that challenge, exploring data. They will give you data, and you are expected to practice this challenge and push this challenge in your GitHub repository. So we'll explain the details next week. And this is for each session, we have what we call assignment. You can see it. For each one, we have assignment. So, and this is review and self-study. What this means by review and self-study, what you learn, there is some kind of self-study that you can read to learn more about what is taught on top. This is optional, but if you want to learn more, you can go for this self-study to learn. And finally, for each session, there is assignment. So you can see the assignment here. So you can see each session there is assignment. So inshallah, next week we can dive into the details to show you how you can achieve all of this.